Okay, so here we're doing the properties of parallelograms and rhombi. So you got to be able to construct a parallelogram, construct a rhombus, prove the properties of the parallelogram, prove the properties of a rhombus, solve problems using the properties of a parallelogram and a rhombus. And the key is to understand this parallelogram congruent parallel side theorem. What do you think that has to do with? If you're thinking about parallel sides, congruent, that makes sense that parallel sides would have to be congruent. So we're going to work on that, okay? And these are your learning goals. Hopefully, when we construct these, we're not going to do these with paper and pencil this time or anything, but I hope you do remember the technique that we use for finding parallel lines. And I'm not going to go through it right now, but that would be good for you to know. And also for creating a rhombus. So let's start by well, actually we'll go through this here. First thing they want us to do is draw a parallelogram with two diagonals and label the vertices. So it says squares and rectangles are also parallelograms, but don't draw a square or a rectangle. So we're not going to cheat and make it easy and just draw a square or a rectangle. We're going to draw one side and then we'll make another side, right? So it's not a rectangle and it's not going to be the same length, so it's not going to be a square either. I'm going to try to draw this side to be parallel to that one. That one's ugly, but I'm just assuming that it stays on this line right here. Oof, that's bad. And then goes down like this. Okay, and there we have a parallelogram. We're going to just call that a parallelogram. This side and that side are parallel. This side and this side, that ugly side up there, those two are parallel to each other. So we have a parallelogram. And the vertices and the intersection of the diagonals. Okay, so we have A, right, B, C, and D. So what do we know about these so far? Well, I don't know. If I draw a diagonal here, let's try drawing some diagonals. If I go from B to D, I mean, I know these two sides have to be the same length, and these two sides have to be the same length, and this side has to be the same length. So I know I've got to have congruent triangles here, right? They've got to be congruent, which means this angle has to match that angle. It has to. And the same thing with this angle and that angle, right? This angle and that angle have to be congruent, right? Because these are another way to just know this for sure, right? If these lines are parallel, then this angle here and this angle here, they're alternate interior angles, right? They don't look congruent because of the way I'm not very good at drawing them, but they would have to be congruent. And also this angle here and this angle here would also have to be congruent, right? Because they're alternate interiors too. So I have angle, angle, right? The green angles, the blue angles, and then this side in the middle. So by angle, side, angle, these two triangles have to be congruent to each other. And then that means by CPCTC, right? Now I know this angle and this angle are congruent to each other. Well, can I just go through that entire same exact argument now, but let's use, I don't know, let's use another completely different diagonal, one that goes here. Well, then this side is congruent to itself. Get some different colors in here and making a mess out of everything, but this side would have to be congruent to itself, right? And what else do I know? Well, these are alternate interiors, so this angle and this angle have to be congruent, right? And, oof, this is such an ugly color. Let's try this guy. And this angle here would have to match that angle there. So by angle, this kind of brownish red, side, diagonal, angle, this other ugly mustard, these match this mustard, this side, and that brownish red. So again, the diagonals, what they're doing is they're creating congruent triangles, and that means the angles and all the parts have to be congruent. So opposite sides have to be congruent, right? The opposite sides, the opposite angles, every part has to be congruent because they are corresponding parts of congruent triangles. Whew! Alright, what about the diagonals? Are the diagonals the same length? I don't think so. I think this, yeah, it's kind of It's like they took a rectangle and they're leaning it. So this blue one gets stretched out long, and A gets closer and closer and closer to C. So this one's shorter, and this one's longer. So the diagonals are not bisecting each other. Or actually, well, wait a minute. Now the diagonals might be bisecting each other. We didn't say anything about that. But the diagonals are not congruent to one another. That's important to know. Okay? Whether or not they're bisecting each other, well, we have to work through that here in a minute. Okay. So now they want us to construct a parallelogram. Okay, so let's use GeoGebra for that. Oops, go to GeoGebra. And I'm going to get myself going on a new page here. So what do I know? If I want to make a parallelogram, then I have to have a side. And I'm going to make this side be parallel to another side. So let's just draw a segment. I'll just draw one. And I'm going to draw another one that starts there and goes, let's say, that way. Now, I need a line that's parallel over here. So I'm going to use my parallel line tool here. Oops, construction menu. Chrome is freezing up on me, so just be patient with me here. But I am going to use my parallel line construction tool. I'm going to construct a line parallel to this one that goes through here. So watch. Parallel line tool. It needs to go through this point and be parallel to, oh boy, I did that wrong. Let me hit the undo button. Oh, I hit escape and undo. And let's get going on this parallel line thing again. Alright, let's say I want to be parallel to this line and go through that point. To be parallel to this line and go through that point, right? So now these two lines are parallel and these lines are parallel. And now I just got to get my intersection tool here to find out where those two lines meet. And now I have 4 points, so I can construct my polygon. 1, 2, 3, 4, and back again, right? And what I think I can do is I think I can hide the lines now that I don't need them. So I just have a polygon, or a parallelogram, sorry. And if I want to, all these blue dots, I can adjust them. So I can make a lot of different parallelograms. But no matter how I want to shape it, it's still a parallelogram. See how these diagonals, here this diagonal will be so short and that diagonal will be so long. So I know the diagonals are not going to be congruent to each other. But the question is, what else can we do with it? Well, let's go back. They wanted us to construct it. We've constructed it, right? Now they want to prove that the opposite sides are congruent. So how do we do that? Well, I would use this PRG, right, is congruent to RA, wait a minute, RPA. PRG is congruent to RPA. Okay. And they say PGR and, okay, they want us to use PGR and RAP. That's fine. And we're going to prove the opposite sides of the parallelogram are congruent. Okay, so let's just do this. Watch. Pretending this is that what was it? PARG. Okay, so here's PARG. So I'm going to use I'm going to make a diagonal. So let's get a segment tool. Here's my diagonal. All right, because this diagonal divides us into two triangles, and these are parallel lines, therefore these are alternate interior angles, and alternate interior angles are congruent. So I'm going to measure them here. Oops. I'm going to measure my angle and show you I know what I'm talking about. Okay, and then I'm going to also measure this angle here. Oops, escape and go the other way. Go this angle to here. Angle measurement tool. Again, and we'll go here, there, and there. Alright, so because they're alternate interior angles, these two had to be congruent. And indeed they are. And even if I start messing around with this, they always will be congruent. They always will be because they are alternate interior angles. Isn't that a beautiful thing? All right. Now, so I have these angles are congruent. By the way, this side is congruent to itself by the reflexive property. What about these two? Well, guess what? These lines are parallel, right? So therefore, these are alternate interior angles as well. So I can claim that they are going to always be congruent to each other. Let's see if I went the wrong way again. Let's try that one more time. I'm going to go this way. Boom, boom, boom. And let's try boom, boom. So, because of alternate interior angles here and here, alternate interior angles here and here, so by angle, side, angle matches angle, side, angle. And therefore, we have proven what? That the two triangles are congruent. So if the two triangles are congruent, by CPCTC, no, it's getting late. By CPCTC, what do I know? Well, I know that each of these sides from here to here has to be congruent to here, right? Because they are corresponding sides of those triangles. And that side has to be congruent to this side because they correspond as well. Okay? And I can see that information is true and remains true even if we change the parallelogram. Okay? Those measurements always stay the same. They're always congruent opposite sides. So we just proved opposite sides have to be congruent because we have two triangles that are congruent. And also, what does that mean about these angles? These angles have to be congruent, right? Opposite angles have to be congruent. And then if I drew the other diagonal, I could use the same logic and these angles would have to be congruent. So opposite angles are congruent, opposite sides are congruent in all parallelograms. That's pretty good, man. All right, you could write that out now. You have the information you need to prove that the opposite sides are congruent. You will make your diagonal and you'll use angle, side, angle with the reflexive property and alternate interior angles to show two triangles are congruent, and then you'd be able to prove that the opposite angles are congruent. And let's see, you could, okay, so to prove that all the opposite angles are congruent, you would need to draw a different triangle. So you would draw the triangle with the different diagonal, the other diagonal. But you use exactly the same logic and you could do the same exact proof again. Use triangle APG and triangle GRA in the diagram from question 3 to prove that opposite angles of a parallelogram are congruent. So we would make the parallelogram and we would make that proof. Once we prove those triangles are congruent to each other, well, then we could prove that the opposite angles, which are CPCTC, they would have to be congruent as well. Okay. And they want us to show the diagonals and that they intersect at point M, and then show that those opposite angles, angle P and angle R, are congruent to each other. Okay, we're not going to do that because we've walked our way through that. So now they want to know, prove that the diagonals of a parallelogram bisect each other. Ah, this is a little different, right? All right, let's take a look. The diagonals of a parallelogram bisect each other. So again, let's go through making our other diagonal here. So here's a segment. Boom and boom. So I make this diagonal. What do I know about this angle here and that angle there? Well, they're alternate interiors, right? So they have to be congruent. I'm going to measure those angles to prove it. Here is... I always forget which way to go. All right, here we go. Let's go measure this angle from here to there to there. You can see that angle there in a minute. From here to there to there. Okay. That proves that, I mean, this demonstrates it, but we knew these were going to be congruent by alternate interior angles, right? Alright, so now that we have these, this is 26.57 and this is 26.57, so we have an angle here, an angle there. We have a side and a side. We already proved we're congruent because opposite sides are congruent. We have this angle 106 and this angle 106. So by angle, side, angle, angle, side, angle, these two triangles have to be congruent. If these two triangles have to be congruent, guess what about these sides? The sides have to be congruent. So let's find the intersection point of the diagonals. I didn't do that very well. Intersection point of this diagonal and that diagonal. There it is. Okay, so I know these two triangles are congruent. Therefore, this segment from here to here must be congruent to this segment from here to here, and this segment from here to here must be congruent to this segment from here to here, and we're going to measure it and prove it. So here we go. Measure the length of from here from C to there, it's 2.1. That's C I guess, and from I to B, and then from I to D, and from I to A. And we see that they are congruent because these two triangles we just formed were congruent by angle, side, angle. So by CPCTC, these parts that correspond always have to be congruent. And guess what? That's true for any parallelogram I want to make, right? It doesn't matter how I make it. These diagonals are going to bisect each other. So that's for all parallelograms. And guess what? Rectangles and squares are both parallelograms. So we know that the diagonals bisect each other, not just for those two, but for all parallelograms. All right. Ray told his math teacher thinks a quadrilateral is a parallelogram if only one pair of opposite sides is known to be both congruent and parallel. Aha! So what if I only knew, let's say, this side and this side were parallel and this side and this side were congruent? Well, if I know they're parallel, I'm halfway there. What I need to know is, are these two parallel? And how would I prove that? Well, I mean, that would be tough. I know these guys are parallel. I know they're congruent. So what could I do? Well, if they're congruent and they are parallel, I could draw this line here. These angles would have to be congruent to each other, right? And then I would draw this line here, and these angles would have to be congruent to each other. And so by angle, side, angle, these two triangles would have to be congruent to each other. If the two triangles are congruent, then I'd have this side and this side have to be congruent to each other, these two diagonals. And this diagonal would have to be, these halves would have to be congruent to each other. So now I have two triangles, and the vertical angles are congruent to each other, right? So by side, angle, side, side, angle, side, these two triangles have to be congruent to each other. And if these two triangles are congruent, then the opposite sides also have to be congruent. Therefore, we know they are congruent. And then what we could do is we can, when we have two pairs of opposite sides of congruent, two pairs of opposite sides that are congruent, they must be parallel. But how can we actually prove that they're parallel? Well, that gets into, there's a couple different ways to prove that, but I think we're going to get into some coordinate algebra here, and coordinate geometry here in a minute, where we're going to start looking at slopes and measuring slopes and stuff. But clearly one of the ways that we could do that is we would, we could do a right triangle, and we would do rise and run of the right triangle. We can measure that. I don't want to mess with that right now. Let me just think for a second. How would we prove that that these sides are parallel? I don't know. Skipping it right now. Come back to it in a minute. They are parallel. We know they're parallel because we know they are congruent. So the question is whether or not they're parallel. And we would have to prove that in a minute. And I'm not going to. I'm just drawing a blank for a minute. So that's how that goes. And I'll come back to it in a minute. And the answer is yes, it is true. I think what we have to do is we have to go back and just start using all the other angles to show that these two triangles are congruent to each other like we did. We already did that, so then all the angles have to be congruent. Then if the angles are congruent, then the line, I don't remember. I don't remember. We'll have to come to that in a minute. All right. So anyway, that is the parallelogram congruent parallel side theorem. It says if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So we can prove that a quadrilateral is a parallelogram by just proving that one pair of sides is both parallel and congruent to each other. Okay? All right, and that is where we're going to stop for the day. We're not going to get into the rhombus. We'll do that the next day of class. And that's the perfect time to stop. And I will try to figure out what I'm missing here to make sure that it's a parallelogram. I can't remember. Thanks.